It is a renewable energy and very readily available in our planet. Okay. Second advantage is what I said just now. It produces zero carbon emission. Because comparing to our petrol car, which produces carbon dioxide, which is a bad greenhouse gases, which will cause global warming. This type of fuel cell produces water vapor, which is doesn't contain any carbon and it is not causing global warming.
Okay.
Yeah. And then the third advantage of this fuel cell is it contains the fuel cell itself is highly energy efficient. Comparing to petrol, this hydrogen fuel contains more energy per kilogram of the fuel inside same amount of fuel. It contains more energy to power up your car, so your you can carry less fuel to travel the same distance in the same car.
Oh, I see. It carries more energy per liter than petrol, eh?
Yes, correct.
Oh, okay.
So that is all I would like to share about the hydrogen fuel.
Okay, thank you very much. James, just one question, eh? The engine itself, how does it compare to the weight of the internal combustion engine?
The engine first is not using the engine, it's using electrical motor.
Direct motor.
Comparing to
Drive,
internal combustion engine,
it'll be lighter. It'll be like Tesla.
Lightweight comparing to fully electric car.
Yeah, okay. Thank you very much for sharing, yeah? Okay,
yeah, no
well
problem.
done, Elon. Okay, I'm impressed. Well done.
Thank you.
Okay, next.
Also, they have the use of cotton, a flag, and knaf. Knaf is now becoming popular because it's it's a plant. Yeah, this plant is the most planting in this Southeast Asia, and in Malaysia also looking forward. Still in the study to introduce this knaf to replace with this as a natural fiber, bring the automotive component. So this is the best graph that I can find in the internet. So I can see from this natural fiber usage, for the automotive is only a very small percentage use. It's only 9%, and most of this application using the packaging. So with this benefit that I can see from this natural fiber placement, I hope in the future in the automotive industry will use more and more natural fiber as a replace to our existing metal part kind of. Yeah. So that's all for the presentation.
Okay, so this is going to be used as a stuffing for car seats, you mean?
Not only a car seat. It's this application used for the any other
or any other
the
parts
car
of the
component. Yeah.
car.
Yes, yes. The door panel, headlining,
Okay.
everything. Yes. And the benefit of this is very lightweight compared to our existing part.
Interesting. 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 Yeah.
Kazan, I have a question.
Yes, yes.
This you talk about the green sustainability transition in automotive. Actually, natural fiber is cannot be something cannot be recycled. It's a plastic material mixed with natural. But
Yeah.
nevertheless, this material cannot be fully recycled compared to steel or aluminium, because you recycle a steel and aluminium, get back a steel and aluminium. But you cannot recycle this natural fiber composite, and it also cannot be degraded. So how do you
You
ensure
can,
that composite is actually green?
I guess you can take it to the recycling
From this,
center to make toilet paper.
sorry, Captain. Right?
Okay, tak apa, continue. Just a remark. Okay.
Yeah, yeah. So the study also they claim that this is good for the
Okay, has everyone finished presenting here? Who's presenting here?
Yes, we all done.
All done already.
Yeah, because Master Poo was already present the big group, so only left 3 of us.
Okay, thank
to
you.
present.
Okay, hang on. Hang on. Let me check on the other groups. Finished. Okay, this group finished?
Yes, already finished.
All finished, yeah? Okay, good.
Yeah.
All right. Has this group finished?
Not yet.
Not
We
yet.
just
Who has
finished
not
one.
finished? Didi.
There's 3 of us yet we haven't present, so
Three of you have not presented. Who?
John Wick presented. Yeah.
Sorry. John Wick has
Wick.
presented.
Yes, yes.
Gavin, have you presented, Gavin?
Haven't.
Haven't. Okay, can I move you to another room for you to present, yeah? So we can finish this faster. Okay, let me send you to room 3. Okay, let me do that again. Okay, Gavin, you go to room 3 and present. Okay, so who else here other than Gavin? Kelly, have you presented, Kelly?
Not yet.
Not yet. Okay. Okay, go ahead. Hello, guys. I have sent Gavin here, Gavin to present in this breakout room, yeah? Okay, slideshow. Gavin. Oh, interesting. Okay, you can start. Can't hear you. Switch on your microphone, Gavin. We can hear you now.
Share screen.
We still can't hear you. We cannot hear you, sorry.
Hello, can you hear me?
Now we can hear you. Okay, continue.
Okay. So I would like to present the application of artificial intelligence in automotive sector. Uh, from next slide onward, I will just use AI as a short form. Okay.
All right.
So the benefits of using AI in automotive sector, so basically there are 4 points to look at. So the first point is safety. Then second point is performance. Third point is cost. Fourth point is efficiency. So I will elaborate further in the next few slides.
Okay, good.
Okay, for safety, so by using AI in the automotive field or the car itself, so the car will analyze from the database. They will check the driver behavior and then try to actively avoid accident from.
So Taiwan is leading. Taiwan is one of the biggest players in electrification of motorcycles. They have a company called Gogoro, one of the pioneers in this market. They have developed a whole system of battery swapping in the region. They have stations where batteries can be charged, taken out, and replaced. There's 370,000 riders in Taiwan using Gogoro's network, 175 million battery swaps a year, 265,000 a day. That is significant amount of batteries being exchanged in 2,000 Gogoro stations around Taiwan. Now, this is a good study, show the usability, day-to-day usage of battery swapping technologies in everyday life. This is practical, this is easy, and it seems to work, and we can totally adopt something like this. Now, it's growing fast. The market is growing fast between now and the future. It's going to be projecting 10% growth annually. We're going to reach billions, hundreds of billions of US dollars of market share in 2030, which is about 8 years from now. So we do not see this as a small piece of pie. This is a big pie that we could really get our hands into. Especially now we have almost zero competition in the region, Malaysia. Once we have our own bike brand, we can monopolize, or we can just be the first runners. We can be pioneers in our own country. So when should we start? When should we start looking towards the future? Now is the future. Now is when we should move our feet, move our minds into electrification, because there's nothing like being the last in a very important race, which is, well, the future. The future is unpredictable. With the current economic crisis, global energy crisis, we're seeing fuel costs, energy costs skyrocketing in Europe due to, of course, a war in Russia. I mean, in Ukraine, Europe is suffering through immeasurable energy costs, and electrification sustainability is always smarter. Trying to be independent from fossil fuels is the way that we all should be striving to. We also need to look into, unfortunately, government incentives in this point, because if like the chicken egg thing, if no one starts something, nobody will ever get anywhere. Government incentives, in a way that they start building either infrastructure or giving independent companies or private companies some tax incentive to build infrastructures around the country would be nice. At least the companies are not having to take the brunt of the initial costs of building electrification ecosystem around the country. And with the help of the government, we can kickstart a brand new infrastructure of electrification. That's what I think.
Okay.
So I think all we have to understand is the future is now, and we should not look into staying in the past. Thank you, Sukian.
Okay, very good, Didi. Okay, so you are suggesting that we should kickstart this initiative, yeah? Battery swapping for electric motorcycles, yeah?
Yes.
Motorbikes. Okay. Interesting.
Because we're going to be too late if we don't start anywhere now.
Yeah. We've always been too late for anything. Okay, well done. I am impressed. I hope that I will be able to get to see you present live, yeah? No, I mean, see you physically present on camera, okay? In the later session today. So who has not presented? I think we have one more. Well, do we have another presenter here? Or has everybody presented? Kelly? Will you be presenting, Kelly?
Yeah. I will present now.
Okay, I think you are the last one to present, yeah? Can I close all the rooms and get you to present in front of everyone?
Oh, okay.
Okay. Okay, so who'd like to start presenting here? Okay, come on. Can I have a presenter in this room?
Logo.
Okay, very good.
Yes, electrical bus.
Please use screen share.
Wait. Oh, I already done
Slideshow.
this then.
Yeah, okay. Wow,
Okay,
very
Captain, I
clever.
already done this then.
You already done so fast.
Yeah,
So
just a
fast.
simple one because I'm
Okay, it's okay.
just
It's
a
okay.
few
What
just a
was your
few,
call to action? Therefore,
logo proposal for EV bus logo.
So what is your call to action? The final line. Therefore, I hope that the management will accept my.
Oh, therefore, I really hope that management will accept my ideation for the bus logo.
Yeah, okay, very good. However, ya, tunggu sekejap, Shizuka. Go to
Yeah,
the
yeah,
first
yeah.
slide. Go to the first slide.
Wait, okay.
Okay, be very careful. You are a designer.
Yeah.
You are using dia kata tu this photo by unknown author is
Author.
licensed. Oh, tu maksudnya boleh pakai. Okay, tak apa. Yang tak boleh pakai tu yang ada watermark tu.
Betul-betul. This one I ambil dalam slide punya apa tu
Tak apa.
PowerPoint punya tu.
Ini boleh pasal ini common license. Okay, no problem.
Kalau dekat Google tu dia tak boleh direct ambil.
Pasal kita designer you must have higher standard kan?
Yes, true.
Nanti orang ambil your design pula kan?
Betul.
Okay, very good.
Okay,
Very good.
thank
Okay.
you.
Okay.
Okay, next.
Will start spreading until the end. It will cause fractures, which is the last stage. So how we going to conduct fatigue failure analysis? So there's one method that we use commonly, which is fractography. Fractography is the science of revealing loading condition and environment that cause the fractures by a three-dimensional interpretation of the appearance of a broken component, which is we are able to read something by looking at the fracture surface, the broken surface of the broken materials. Because whatever happens on the material, it will leave marks. Different type of loading and different type of stress, it will cause different type of mark.
Different
so
mark.
as you can see, as you can see at the right hand side, starting with the nucleation, you will have a small void. As the crack grows, you can see there will be a wave front-like structure mark propagating from the nucleation spot towards the opposite.
Propagating from the initial spot, to the opposite end.
So as the crack grows until to a point where the surface connected is so small and it can no longer withstand the stresses, it will have immediate fractures, which is the number 4 figures. You can see the diamond shape is the immediate fractures, where it will happen within a split seconds. The whole material will be broken into two. So as we see the right hand side, you can see this is the common appearance that we see at a broken component. So you can, from there you can identify 3 stages and how it grows, from where it grows and where it ends. So from there we can start to identify what actually causes. Maybe there's a collision.
Okay, hello everyone.
Okay.
So next I will be presenting my proposal.
Hi, Luffy. What are you presenting?
Wait, I sharing my screen. Okay,
Radiator
can
assembly.
everybody see? Yeah. Okay, so today I would like to present the Radiator assembly design proposal for new project.
All right.
Okay. Okay, so this is the specification study and proposal. Okay, for the customer requirement, they have this requirement for the core AC fin pitch, the frontal area cap opening pressure, and also the heat rejection of the radiator, which is a 42.9 and also 48.9, which is we are required to propose two specification to customer. Okay, so for proposal 1, we are going to use our 16 mm CMKP core, which the core size will be 450 times 448.5 times 16 mm. Using the fin pitch 1.1 CMKP, this design will able to produce the heat rejection of 43.8 kilowatts, which is will be matched with the first design requirement from customer. Okay, so for the proposal number 2, we are going to use a 16 mm core using the fin height 6 mm. So the core spec is same as per customer requirement, and fin pitch is 1.15 with a 6 mm fin flat top design. So for this proposal number 2, this design able to produce the heat rejection of 50.46 kilowatts. Okay, this is a performance study for proposal 1. So for the proposal 1, the heat rejection is 43.8 kilowatt compared to customer requirement 42.9. This is the estimate performance on different water flow rate. And this one is the proposal 2 for the design number 2, which can produce 50.46 at 40 liter per minute, also 60 liter per minute of flow rate. Okay, for this radiator proposal for number 1 and number 2, this is a tooling and jig need to be developed for this project. First one is a tank mold. Second one is the header plate and PRC die, seal pack mold, auxiliary and core jig. Also, we need some machine modification since we are going to use our 6 mm fin pitch. So our existing 7.5 mm fin pitch will need to be modified to 6 mm. And also we are going to use to develop our new inspection jig. Okay, that's all for this proposal.
Therefore, I hope
you will consider this proposal to be accepted and approved by your side.
Okay, very good. Okay, very good. Yeah. Did you mention what problem your proposal is solving at the beginning of your presentation?
I'm stated the customer requirement.
Customer requirement, yeah. Yeah, we don't have a radiator assembly that meets the customer requirement. So therefore, we have designed. Therefore, the need for us to design a radiator assembly that meets this requirement. Yeah.
Yep.
Okay, very good. So proceed. Continue with the next one.
Okay, thank you.
Okay, well done.
The concept. So this is how the industrial design team in APMER does your design work in general. That's about it. Thank you.
It looks like an airline seat. Is it comfortable?
Better be.
Better be. Hey, Didi, what problem does your solution solve? Did you mention that? Did you identify the problem at the beginning of your presentation, Didi?
Oh, so what I'm doing for my presentation today is not to show product. This is a general, what do you call it? This is a general showcase of how the design process works in this company. Oh my God, that's the 5. Never mind, I got it.
Design process.
Yeah, we showed the general design process in APMER, how we start from A to Z basically.
Maybe at the end of it, therefore, I hope all of you will use this process when you design items for vehicles, yeah? This ideation process, which has
Yeah,
proven to be superior. Yeah? Okay. Okay, Didi, well done. Next, please.
Okay. I'll stop this.
Next, please. John Wick. Okay.
Okay.
I'll come back to you. Child seat.
Yeah. So this also I like to promote to Captain by child seat. It's a product. It's a product by APM. We have a 2 version of color, blue and pink. So you can see this product.
I didn't know that APM produces child seat.
Yes. Yeah.
Where's
you,
the outlet?
Captain.
How do you sell? Which
No, you
channel?
You just text me, then I get a product for you anytime, anywhere. Yeah. It's only 288 ringgit. Very cheap. You cannot find. Yes, you cannot find this so cheap a product in the market.
288 ringgit, and it is this ISOFIX, yeah?
Yeah. ISOFIX. You have all these feature available.
Wow. Okay.
You might be thinking about this first. Yeah.
Yeah, I will take up your offer soon. Yeah.
This is recording. This is recording. Then you can share to your friend, lovely wife, so on.
Yeah. Well, I like it because it includes ISOFIX, so very good.
Yeah.
Okay, well done.
All right.
Wow, APM. You produce all sorts of things. You produce radiator. You produce dampers. You produce shock absorbers. You also produce child car seats. Incredible. Yeah, incredible. I am impressed with APM. Okay, continue, guys. Or has everyone finished presenting here in this room?
Mr. Lee Zijia.
Yeah, Lee Jizia. Okay, Lee Jizia. Lee, where are you? I heard you're not playing badminton anymore. You're on long leave. Ada ke Lee Jizia ni? Okay, Shizuka, please get Lee Jizia to present, yeah?
Seat offset. We make it as adjustable seat offset. This is one of the parameter that we need to control as per our customer requirement. So and also this image also make it lighter than the conventional concept and suitable to be integrated with commercial PC. This is what I mean by hybrid concept, suitable to be integrated with the existing PC. Okay, so what we can expect from this invention actually? First is this, we can speed up our prototype process by eliminate the time to fabricate the common chip. Usually will take about 2 until 1 month to complete. So with this kind of invention, we can save that time during prototype stage. And then we also can reduce a large number of gadget inventory list, which is keep expanding from time to time. Okay, as you can see in this picture, the usage of the massive rack. So we can eliminate this kind of method and save a lot of space to store all the conventional jig. So I strongly recommend and confident that we can meet all these expectations if we proceed with this invention and implement this in our prototype, first print prototype process. That's all from me. Thank you.
Okay, thank you, Eliud. Can you go to your final slide?
Final slide. This one.
Yes. Okay, so for the first two item, which is the speed up prototyping and reduce large number of guide jig, you have used vector drawing. Okay.
Okay.
Vector drawing or line drawing. Okay. However, in the third item, which is eliminate the usage of massive rack and space, you are using real photo. Okay. So if you use line drawing, keep all the same line drawing. If you use real photo, then make sure that you use real photo for all the icons. Yeah.
I agree with that.
It would look better that way. Yeah. Okay, Eliud.
Yes. Yes.
Okay. Well done.
Okay. Thank you.
Okay. Impressive as always. Well done. Okay. Has everyone finished in this room? Has everyone finished presenting in this room?
Yes.
Kan ada lagi? Iman?
Iman ada meeting.
Huh?
Iman has meeting, he says.
Has meeting, okay. So has everyone finished?
Saya ada line item kat bawah. Dan.
Iman ada
Has
dekat
everyone
plan.
finished? Semua dah habis?
Yes.
Nak finish, I ada line meeting dekat production.
Okay, hang on. Let me check the other rooms if they have finished, okay? Let me check.
Okay.
Yes, Captain.
Okay, has everyone finished in this room?
Yeah.
Okay, very good. Okay, I think everyone has finished in this room. Okay, let me check the other room.
So,
oh, Master Po is presenting. Continue.
Yes, I am. So, other than complete capability on conceptual design, we are also capable of constructing the full chassis as well as the full body electric bus. We are also capable in technology development. For example, the heart of the system would be the battery pack. We can assemble the whole battery pack ourselves. We have a lab that is able to assemble and also test the complete battery pack. We are also able to completely validate the whole system. Meaning to say, every component that is inside the electric vehicle can be tested statically on the bench.
Wow.
So we could demonstrate the protocols. We could demonstrate the drive cycle on bench so that the product that we are going to place in the chassis would be easier in terms of validation. So now we are open for collaboration opportunities in any way possible, including mobility, engineering, data analytics, and sustainability approaches within the company. For teaching and learning, we are also able to support universities, colleges, anywhere, all right, in terms of constructing dedicated buses for their laboratory applications, That's what we call this as mobile lab. We can also establish EV systems labs to demonstrate the application of components within their lab. We are also able to do certain industry outreach in terms of teaching and learning. The plus factor over here is that students who are attracted to this and are convinced as a future endeavor could be selected to work with us in the future. Thank you very much, guys. As a token, I would like to attract all of you to accept the proposal so that we can push for further collaboration. Thank you very much.
Very good, Po. Which one are you in this photo?
Okay, you missed the first slide. Let me.
You appeared in the first slide. Okay, not in the final slide.
Yeah.
Oh, that's you.
Yes, that's me.
Okay, so you don't look
I'm
like
the driver.
You don't look like Po at all.
No, I'm the driver.
You
That's
misled me, yeah. I was imagining a big fat panda.
I told you so. I'm the opposite.
Okay, okay. Well done. Like your slides. Good use of the designer function. Yeah.
Yeah, it's good actually. Very interesting because I just pick up from what I have presented earlier. And this would be a good one because that it is clearer in terms of image integration into the words.
Yeah, and it makes designing slides much easier too, right?
Yeah, very easy, simple.
Very easy and simple. Yeah, continue using. Yeah. Okay.
All right.
Has everyone completed presenting in this group? Habis ke? Habis? Finish? Gavin, okay, Gavin, go ahead. I'll come back and check on you, yeah?
Okay.
Between OE and sport found the spring rate for sport has increased up to 44%. This is consider the limits. For better performance and to prevent front bottoming, it is recommended to change the shock absorber for front. Next item is handling double lane change. Significant body.
Sorry ya Bruce.
Yes.
Ini untuk present kepada customer atau present ke siapa?
Kita present untuk internal sebab kita ada next untuk tuning, finding dia. Ni for first batch. So second batch kita akan find the best tuning untuk.
So the objective is you want to persuade to have another test on this car lah.
Yes, to share the finding for plan lah.
Okay.
So for handling, which is double lane change. For OEM, significant body roll causing delay in changing direction. And for sport car, body roll response in changing direction had significantly improved. Capable to maneuver when with higher speed with confidence.
Okay, ya, Bruce. Tak payahlah baca, je cerita je, tak payah baca. Kau baca satu-satu tu. Capable to maneuver with higher speed with confidence. So, ayat tu penuh kat bawah tu, kau nampak? Okay, Bruce. Satu lagi, penuhkan screen ni. Guna slideshow.
Tak boleh tadi, dah try banyak kali.
Tak boleh.
Tak boleh?
The best thing you can see like this.
Oh, okay. Okay, tak apa. Tak boleh lah. Okay.
So, tadi mana?
Next slide.
Next
slide. Okay.
So, next item is handling slalom. Okay, for OEM, spring significant body roll cause delay in changing direction. So, this one is same as previous one, double lane change. For second trial, using sport coil spring, The body
Kita
roll.
sikit. However, in the second trial, when we use the spot coil spring, this problem was reduced. So body roll, inertia, all this has reduced already. So a lot of improvement over the first trial when we used OE coil spring. Dia kurang macam tu lah. Tak payah tak baca satu-satu.
However, okay.
However, when we change to spot coil spring,
however, after we change to spot coil spring,
Aha.
the body roll response is changing. The direction had significantly improved. And the setup induced has been improved for oversteer characteristic.
However, when we use the spot coil spring, there is a slight oversteer. However, when we use the spot coil spring, there is a slight oversteer, which did not exist when we use the OE coil spring. That's what it means.
Okay. Saya pun pusing.
Kan? Oh, punya result sendiri tu.
Sabar.
Cakap Melayu lah. Cakap Melayu spot coil ni ada oversteer. Tapi kalau guna coil spring yang biasa tak ada. Itu sebenarnya.
Okay, yang ni apabila kita guna spring coil yang spot, kita boleh remove oversteer punya karakteristik.
Tidak, dia kata the setup induced slight oversteer characteristic. Maksudnya ada. Bila guna spot coil tu ada pula oversteer. Tapi guna coil spring OE tu tak ada. Induced tu mewujudkan. Wujud. Kan? Maksudnya walaupun body roll dengan respon tu bertambah baik, tetapi ada pula sedikit oversteer bila guna spot coil. Itu maksud dia.
So boleh sambung kan?
Sambung terus.
Okay. So for others sweeping corner, for OEM, the sweep corner is less stable in sweeping when due high speed. Okay, for after we change to spot coil, the stable is for sweeping corner has significantly improved. However, capable to maneuver with higher speed with confidence. So for conclusions, based on the testing spot coil spring on Honda HRV, the actual fitment shown the performance is okay and satisfied, but we need to improve for ride height at for rear right and rear left, and need to increase the height with increase of height of speed. Next, we target to our target is to prepare the new spring and increase for the height about 15 mm.
And to run another test to check the results.
Yeah.
Okay, Bruce.
Okay.
Okay, relax lah, Bruce. Okay. Okay, so very good, Bruce. I like your presentation. Jadi kita tak payahlah nak baca satu-satu, sebab bila kita baca satu-satu kurang menarik. Jadi orang nak dengar ceritanya. Cerita bila kita pasang OE coil, lepas tu kita tukar kepada spot coil kan. Apa perbezaan dia, cerita je. Kan, tak payah baca satu-satu ya. Okay, very good. Okay, dah habis ke semua kumpulan ni?
Ya.
Habis dah. Okey, kejap saya cek satu lagi kumpulan ni dah habis ke belum?
You will do the physical task.
Okay, has everyone finished in this room? Didi?
Yes.
Has everyone finished presenting in this room? Finish, yeah?
Yes.
Right. Okay, let's get back to the main room.
What about this? It's a full view or slide. Okay.
No,
we can't see you.
Oh, I cannot see. Alright.
No,
Yeah, share. What about this?
Okay.
Okay. All right.
Good.
So, hi everybody. So today, what I'm going to explain to present today is about a design of experiment, or someone called DOE through CAE simulation. So in this present day, we can see many design parameter. There's a critical step is to find the best possible experimental setup with a minimum number of simulation. So in this situation, designer use their intuition. Okay, intuition. Oh, very
Bukan
hard.
institution.
Intuition.
Intuition ni maksudnya bisikan hati.
Wow. That's the bad thing about copy and paste.
Tak apa. Maksud intuition adalah bisikan hati. Ikut gerak hati.
Okay. To experience to carry out a number of simulation runs and choose the design that give better performance. So what I'm going to show here is a DOE that we are run through CAE simulation. So this there's one case study we did for our seat. There's a
baby seat.
Yeah, you see you have a plastic part at the side. They call a shield cover. So from this simulation, what we find out that by positioning the gate, it can help us to hide certain the outmark, like a well line here. So of course the well line is up here because this the meeting point of these two chemical, but we can position the well line as our desired location. So because when we position here, it's actually can hide with this another part liver, so it's look very prominent. Another case study here is this the center console is appear of the silver streak up. So what we did a study previously, when we first run, you can see some the volume appear at this area. So by do some study increasing a number of thinness, and this
it was started have nucleation, and this nucleation will cause a 45-degree fractures. So the very obvious appearance of the stage 1 process is fracture surface orientation. As you can see in the right hand side bottom figure, it will appears growth into a 45-degree fracture origin. So next, we need to identify where and how it travels. To find out how and where it travels, we need to find out the stage 2 appearance, which is the benchmark and striation. As you can see in the figure, it looks like a wave front lines.
Right.
It doesn't. It's not as obvious as the previous slide. Sorry. As the previous slide. For the actual one is a lot more tighter together.
Mm-hmm.
So moving forward to the last stage, the stage 3, which is the fracture one. This will be shown in surface roughness. As you can see, at the end, the whole surface broken. The surface will leave the fractures will leave the surface a very irregular and rough contour. So through this process, we can identify uh, where does this crack started. From there, we can further investigate how it is made, the crack, how's the crack is made, what causes it, and we can conduct a series of inspection tests on that spot so that we can save a lot of time instead of investigating all the areas. Like for example, if you want to solve for a sore throat, we would not go and check the leg, check the hand, and check the head, check the hair in order to come to conclusion. If we can identify where we need to check, like I know that you are having sore throat, so I will just go directly into the throat and to conduct all the inspection tests we need. So this fatigue analysis is to help us also to shorten down the time, save the expenses, for example, the machine, the time for the workers, the workforce. So in short, last but not least, I would like to urge every one of you to learn and to use this method to identify the fatigue failure before you conduct too much or extra inspection tests. Thank you.
Oh, so that means this is the first test that everybody must conduct, yeah, when investigating.
Yes. You can save us a lot of time and money.
Okay. So as a rule, do a macroscopic test first. Okay, continue. Question, guys. If there's any question.
Yes, that's all. Thank
question.
you.
This is your opportunity to ask. Come on. Come on, guys. Ask question.
Yeah, please put back just now the slide.
For the battery. And I see also it helps achieve the goal by tracking and getting accurate real-time data and also the complete production life cycle. Okay, and I think that's all for my side. Any question?
Any question for MES? Any question, guys? Any question? This is your opportunity to ask. My question is, have you implemented MES?
Partially, yes.
Partially?
Yes, partially.
Partially, yeah. Okay.
Yeah.
So is APM aiming for full certification instead of partial?
We are toward that.
Full, yeah? Okay.
Not full, but we are toward that aim.
Towards that aim, yeah? Okay. Okay, question? Soalan, question? Okay, tak ada. Thank you very much, yeah?
Thank you.
Okay, thank you very much, Adudu. Thank you.
have in front of them. So in this example, we have two models. The one that they are building at the moment is the second model, EBC 0801. So they have these VIN codes on the chassis. So it indicates what are those meaning, the meaning of those codes. All right. So as an overview, that is the chassis. So basically they have this chassis in front of them. They can see all these in terms of ready-made chassis. So I also presented basically the location of components so that they understand what are those things on the chassis. All right, so for example, battery packs. Okay, we have this blue color thing. These are battery packs. The one inside here is also battery pack. All right, we have 4 packs. Huh? So and etc. etc. So on site, actually, we
expand the diameter will expand and increase. So after that, we need to refer the marking scale arrow. We can see at the picture. There we have a scale on the jig. After you rotate the plate, you can set how much is the inner diameter that you want, and then you need to use a vernier caliper to verify the diameter. Okay. So and then and then after that you need to measure with vernier caliper to the dimension, and then after that you need to tighten all the hose screw with the Allen key. And install the jig on the machine platform. So this is how it looks when we put on the machine platform. Okay, next. This is the basic installation method when we try to combine a section A with section B. So actually this is section B. This is section B and this is section A. So we can use both separately. So for this process, for this step is how to combine both sections. So first install the adjusted section A on previous slide, on previous step with upper rotating plate with a bolt. Okay, and then after that we need to install we need to install off center plate to the machine platform. Okay, and then after that we place the lower rotating plate and assembly step, this section A and this lower rotating plate onto the offset center plate. Okay.
Okay, next. Come on, this group.
Hello, I'm going next. Can.
Okay. Okay.
Go ahead.
Okay, can you see my screen?
Yeah, great.
Okay. So good afternoon, everyone.
Afternoon.
So today, I would like to present to you a procedure for self-servicing radiator.
Oh, okay.
Okay. So for the introduction, radiator cleaning is important part.
Yeah, important component.
Okay. For the car to maintain its performance and the service life. Okay. So this radiator actually is a engine cooling parts, which can cause a very bad effect to us if we are not servicing it based on the recommendation. Okay, so for the radiator, it's recommended to service every 12 months or 30,000 kilometers. The purpose is to remove all the rust and residue built up by the coolant. Okay, so here is the general radiator system. So if you went to any ICE, internal combustion engine car, the system for the radiator is similar like this. They have the radiator, they have the reservoir, they have the thermostat, they have the hose, upper and lower hose, also the water pump. Okay, here is the basic system for the radiator. Okay, so how to service? Okay, so the service procedure for the first one is the inspection. First one, we have to keep our safety to do any servicing job on our car. So it's important for us to wear the rubber glove and the safety glass. The purpose is to protect us from the heat and dirty fluids.
Okay, is anyone presenting in this group? Is anyone presenting in this group? Is anyone presenting in this group? Tak ada? Finish.
Finish already.
Finish, okay.
So that we access. So on the left-hand side, at the rear side, we inform them this is the opening, the height of the opening from ground. Right, from the side view, the dry battery access door location. For the water tank, water reservoir location on the left side. The charger plug location. And then from the bottom side,
of this reclining angle, just change the center plate to have a different degree angle, right?
Yes, yes.
So you still can remain back all this as upper and lower body jig. So just change the center jig to have a different angle.
Yes, yes. We need to just rotate this plate on the center one.
Good, good. And
but if possible, please do the checking, the inspection.
Oh, so meaning that the red color, that one is you need to use the thing you need to clean up.
Yeah, because the coolant actually it can give us the residue because it's attraction with the tube and header plate, everything, the aluminium part one, it will cause some not corrosion, it's like sand things inside. The chemical reaction, yes. So we have to check that one. Some of the radiator, they get very rusty because that one is built up for so long. Yeah, so any more questions?
So how often you clean your radiator?
For the radiator, usually, first one, like I said,
yourself.
Oh, myself. Myself, I think 6 months.
6 months.
Yeah, because I'm using Saga, so using the old coolant one.
Oh.
Yeah, because for radiator, actually, it's recommended for us to use the recommended coolant because the design wise.
Yeah.
Because
I thought the radiator system is a closed system. So do you need to?
No, for radiator we have two type of system. Which one is a closed, the other one is open. Like what I present to you is a open system one.
Oh, this is open system.
Yeah, for the closed system one, it's a bit hard to do at home. We have to get the professional to do it.
example, what car, what brand?
For the
Closed system?
closed system one.
Yeah.
Closed system one. I remember last time it's a Renault Kangoo. But not so
Renault Kangoo.
yeah.
The funny looking Renault.
Yes, similar to Canary one.
Like kangaroo,
Like like Canary one.
like canary, yeah.
So what's the difference? Basically, open and close.
Basically for the closed system one, they didn't have this opening pressure cap.
Yes.
And also the drain cock is not located here because this system is closed already. We cannot do anything here.
Yeah.
Yeah. And then after we put up the coolant, everything, we have to check back the pressure so that the pressure need to maintain at certain pressure. Setting by the system, vehicle system lah. Okay, so for this one open system one, this is a flexible one because it's controlled by this pressure cap. Pressure cap is a cap with spring that control the pressure of this radiator.
Okay.
So the closed one, I believe more on Continental, right?
Yes. Yes.
But the Continental also they have so-called something like a reservoir to add in.
Yeah.
So how?
So the ground which area?
The black one.
No. Where you touch to determine the ground? Just a table or any specific? Because sorry, I not electronic engineer, so I don't know how to use this stuff. So where you position, not position, where you place this get the ground.
So at the any component electronic like
Okay.
the resistor, so it has a ground pin or power pin. So we need to check the data sheet.
Not very clear. Okay.
For register, I mean, if you check, for example, 100 ohm resistor, if you put the two terminal on each side of the resistor, will the multimeter make the sound beep?
This thing is only for the continuity test. So it does not matter if the current, how much the voltage or how much the current. So if the resistor okay, so it should be sound bit. If the resistor is not okay, so it will not sound.
So there's no like
yes.
any resistance
Yes.
limit. If it's below certain resistance, then only it will beep. Even this thing will beep even the resistor is a very high resistance.
No. This continuity just only to check if there is current or not. So to check the value is we need to change to voltage or current. I mean like setting to voltage or current.
So how much current it needs to be, you know?
It's regarding to your electronic components.
Okay.
Yes.
So for example, 1 kilo ohm resistor, how much current?
Finish everybody this group? This group finish?
Okay, so the new method I'm using now, I can use the shortcut key. If you test now, you can shift window and S. It's a screenshot. Then you can do the screenshot of any area that you want it. Okay. After you do the screenshot, you just paste to the document. So for me, this is way faster. It's within 1 second, I can do all the screenshots. So if anyone like doing a lot of screenshot or pasting your document.
Baik. Siapa tak present lagi?
Siapa tengah present ni? Finish already, Scott?
Baru habis.
Baru habis?
Gaben.
Gaben, okay, Gaben. Gaben.
Hello, can you see my screen?
Yeah, Mazda.
Okay. So I make it a quick one. So a very good afternoon to everyone.
Use
So,
slideshow.
Is already full screen?
No, it's not.
Not for what? I try again.
When you press the button, your screen will be.
Is it full screen?
No.
No.
Press that button, bottom right.
Already pressed.
Do you have a second screen? Is that what's happening?
No.
Oh, that's weird. Okay.
Okay, never mind. Just continue.
We will put on this case. We call it uppercase onto this mounting jig, and then we will put in the evaporator core just now. We already assembled, fully assembled into this uppercase. Insert evap core into case. Then second step, we will assemble the lower case to the to this uppercase. So like close it together from the upper and lower case. And then
so first of all, we need the ultrasonic fuel sensor, and then we need the epoxy glue, sandpaper, and also the measuring tape. So the next step, first we have to attach the fuel sensor to the fuel tank. So what's important is we have to use the measuring tape to find the center point at the bottom of the fuel tank. Once we have located where that center point is, then we clean that area with the sandpaper. Make sure that it's clean, there's no dirt, there's no rust there. And then we mix the epoxy glue together and apply this mixture to the fuel sensor. Once we have applied it to the fuel sensor, we attach it at the center point of the fuel tank, and we hold it for a few minutes until it hardens. So it will, and once it hardens, just check that it will remain fixed there. And then next, once we have already attached the fuel sensor securely, we have to route
The one of the famous brand, which is Yaskawa, is like a 6-axis degree of freedom welding robot. So the robot will move around based on the program we teach earlier. So after welding process, so the finished product will be passed to final QC area for final inspection. So the photo shown is the final checking fixture. So if the QC confirm the product is okay, then the product will be passed to the packer. So the next photo shows the delivery trolley. So the packer will arrange the product based on the packaging standard agreed with our customer. So after packing is completed, the trolley will be delivered based on the Kanban or coin plan. So from here, I end my presentation. So this is the general flow, regardless the model. So the process flow is actually same regardless the model involved for this item. So do you have any question?
Nope. Okay, are you the last presenter in this group?
Yes.
Okay, hang on, hang on.
Okay.
To hold the two components together. So this is the whole piece of the front HVAC that we already assembled, and then this thing will be installed in your car dashboard, behind your dashboard for your air conditioning purpose. So thank you. Question?
Okay, thank you. Are you the final presenter in this group?
Yeah.
You're the final presenter. Okay, hang on. Let me check group 2.
Drilling, we use the epoxy.
Sorry, again.
We use the epoxy glue. So we have to clean the bottom surface first, and then we mix the epoxy glue.
But the sensor, how do you put in?
It just attached to the bottom surface.
Or
it attached to the external of the tank.
Or is something like a strain gauge like?
Okay, has this group finished? Has this group finished?
Yes.
Yes. Okay, there's one more group who is still presenting. Hang on, yeah. Group 2 is still presenting. Hang on.
PC.
Cannot so easily read the canvas.
Yeah, so a few reasons. So why most of the drivers who attach this is more because they want to see they want to see from remotely what is the fuel reading. But so let's say if you want to use the sensor that is already on the vehicle, you need to how to say, go through the canvas and the data to get that reading, which manufacturers usually don't share it very freely.
Not easy to break the thing.
Yeah.
Okay. Are you the last presenter, Fahmi?
Yes.
This group? Okay. Finished?
Yeah, finished already.
Therefore?
Therefore, I hope my simple presentation shed some light on how we fix the fuel sensor to our trucks, to our customers' trucks.
Oh, okay.
Sorry, Fahmi, your ultrasonic can only sense on metal, or if let's say it's something like now they have something like a fiber tank.
That one I'm not so sure. Have to check back. Because previously we mostly do the trucks is using the metal tank.
Yeah, metal.
Yeah.
Maybe this one need to explore a bit more.
Yeah.
Yeah, now very common with the fiber one actually now.
Mm-hmm.
But
Okay.
most trucks and lorries use a metal tank, right?
Yeah, most now.
Yeah.
Still yeah, okay. Okay, finish yet? Okay, thank you very much, Fahmi. Thank you very much. Okay, let's all return to the main room.
Welcome.